Hi there, I'm Cypher with another video and welcome to this class. And as you can see, the topic of this class is descriptive analysis using SPSS for quantitative variable. And if you are new in my class, you can just click the subscribe button. If you're watching this video specifically from YouTube, you can be notified from my next few videos. I will keep uploading videos specifically from this playlist. It's about SPSS and how can you analyze the data by using SPSS. Alright, so this class topic, actually my goal is to teach you will give you some basic ideas so that you can do some advanced analysis. For the next classes, like I will talk about regression analysis. And before that, I feel that you should know like the descriptive analysis, like mean, median, mode. To more specifically, like the topic I will discuss in this class at first, like to broad areas of statistics. Okay, it's like descriptive and inferential statistics. And moving forward next, I'll talk about like measure of dispersion, measure of central tendency, like mean, median, mode, and dispersion, as I said, like range, IQ or standard deviation, and like I will talk about measure of skewness. Okay, so after teaching you all this, I will show you that how can you find these things in SPSS and how can you interpret the data. And this is very important. Before starting the class, you have to download the data file I have provided you. Alright, if you're watching this video from YouTube, you can check the comment box where you will find the data file and follow the class. And while finishing the basic, you can just follow it in SPSS. Alright, so let's begin with descriptive versus inferential statistics. As I already said, this is two broad areas of statistics. Alright, so like in descriptive statistics, our goal is to describe the data, like give summary of the data, like interpret the data without using probability. That is the most important term to identify which one is descriptive. Alright, like you can do some graphs, and while graphical analysis, this is not your goal to tell about the future. Okay, like you can find different measures, as already mentioned, to describe the data. Say from a data set, you can say that this is the average value of this data set. Alright, so this is not inferential statistics, this is descriptive statistics. And moving forward, what is inferential statistics? Like make judgment and drawing conclusion about population using sample. I told it at my previous class that in statistics, we do not deal with population, rather than we deal with sample, which is a part of population. Alright, so what do? We analyze the sample, then we tell it about by the population, and it's never 100% accurate, as we don't know that, as we don't collect the data from population, and sometimes we even don't know how big or large the population is. We just estimate it. Alright, so yeah, the important thing is that when you interpret the data using probability, that is inferential. And like you can perform estimations, you can do a hypothesis test, you can fit a model to give prediction about the data. So if you still don't understand, let me provide you an example to differentiate these two statistics. Alright, so let's say like at the last election of USA, there were like Clinton, like Hillary and like Donald Trump. We all knew that Donald Trump won in the last election. There will be one more election coming soon. It's between Republicans versus Democratic Party. Now, if I ask you that, like, who will win the next election coming on? Okay, I know this is not like Hillary, but I just posted this picture so that to explain you. Now, if you say that, okay, there is a 90% chance that, or maybe there is a 60% chance that this party will win. Okay, so you're making prediction by which? By analyzing the data. Now, this is inferential statistics. This is not descriptive statistics. Okay, so yeah, moving forward, like I already described, give you some ideas about variables. We know variables, things can vary. We simply understand that. In statistics, though, the definition is a little bit different, but let me move forward with like there are two specific variables, also some other variables, but let me talk about these two specific variables like categorical variable and quantitative variable. I already provided this example, like you can ask people, okay, what is your age? They can tell any number, and this is quantitative. And sometimes in practical life, it is very tough to deal with quantitative data. So what do? we try to convert it into categorical data. Okay, like we give them 5 options, like 0 to 10, 10 to 18. If they choose one particular options, then this is categorical variable because it has categories. All right, and the next one is like to a specific categorical variable like nominal variable, ordinal variable. Say for gender, like you have 2 categories, male, female. There it is not important, like here ranking is not important. Like male or female, which comes first, which comes second, this is not really important. But for ordinal variable, the ranking is very important. All right, like PhD cannot come in the middle. PhD has to be in the top, or maybe in like you can set like 1, 2, 3, 4, 5 at any way. All right, so ordinal variable is that when you categorize the variable in such a way where ranking is very important. I already described it in my previous video. So this video is about like quantitative variable, as I mentioned. Like there are 2 specific quantitative variable I want to discuss. It's like discrete variable and continuous variable. So what is discrete variable? Let me give you an example to understand it more better way. Like, as you can see, like for number of phone calls. For number of phone calls, let's say, like at a day when you may get 10 phone call, you may get 1 phone call, you may get 0 phone call. So it varies. So it is a variable, right? Now, is it possible that you can get 5.5 phone call in a day? Not possible, right? So you cannot take like the fraction value, or like you cannot take, here is mentioned like variables that can only take on a finite number of values are called discrete variables. Some quantitative variables are discrete, such as performance rated as like 1, 2, 3, 4, 5. You cannot take like like 3.5 or 4.5. And for the continuous variable, what I say is that this is a numeric variable that have an infinite number of values between any 2 values. This is a very important point that you can differentiate these 2 variable. Like like between 5 and 6. Can you take 5.5? If you can take, then this is continuous. If you cannot take, then this is discrete variable. For example, height, weight, length. You can take any values between any 2 values. All right. So this is how like you can describe these 2 variables. And this video, as I said, I will specifically show you how to analyze the data in quantitative variable. All right. Now moving on, like measure of central tendency. What is measure of central tendency? Like you have to find a value which represents the whole data. All right. Let me give you an example, like average age of death or life expectancy. For example, like in our country, in Bangladesh, like we have like I can't remember right now. Like we have like average age of death around like 68, maybe 69 years. So when I know that, I can expect that okay, it is possible that I can survive like in 68 years, because like a lot of people die close to these years. So that is how this value represent all the values. Like in exam grade, like we say that okay, the average value is like 3.5. Why you say that? We know that this value is like, it's not the highest value, it's not the maximum value, it's like a value that represent the data. All right. So yeah, it is not obvious that it has to be in the middle. Like we will show some measure. So let's move on, like arithmetic mean. What arithmetic mean is do is like find the sum of all the numbers, then divide the how many numbers, like 4, 1, and 7, 3 numbers, right? So you can just sum the numbers and divide it by 3, you get 4. So you can say that their arithmetic mean is 3. So what is arithmetic mean? This is also a representative value of a data. Like if you say that the value of mean of the like a variable, like which I will describe in SPSS, like highest year of school completed. Like how many years? Some people may complete like 15, 20 years. Some people like may complete only 5 or 6 years in school. So yeah, so if you find the mean is 13 years, then you can say that this represents all the respondents. All right. Okay, so moving on, like median. Median is just exactly the middle value of the list of numbers when we just order the values. All right. Let's say you have like 1, 4, 7, 10, 20. As you can see here, we have an order like lowest to maximum. And which one is the middle? As you can see, 7 is in the middle. Like before 7, you have 2 values. After 7, you have 2 values. So the median is 7. Now, this is most appropriate for ordinal data. It doesn't mean that it cannot use for quantitative data. It's also appropriate for quantitative data, but the most appropriate one is median is for like ordinal data, which is, as I said, is categorical variable. Okay, so and this is most appropriate for quantitative data when outlier exists in the data. What is outlier? Outlier is like a value which is different from all the values. Like how? Let's say like you have a guy in your class whose weight is like 120 kg. Like, isn't it like very different from all other values? Isn't it too much? So a value that deviates from all other values, or that is quite different in practical sense, can be called as outlier. Alright, there are some methods in statistics we use to find outlier theoretically. I will show in this video, like in Boxplot, how we can find outlier. And moving on, like when outlier exists, or how you can like describe mean and median. Okay, let's say salary data. I have only 5 values. Okay, so for some mistake, I have not provided, like I have provided $13 is median, $16 is mean, like this is like $13,000. All right, so I have 5 values, so consider it as $1,000, which I have not provided from some values like by mistake, like we have 10,000, 20,000, 30,000, 40,000, and one person having like 200,000. All right, so this is the 5 values, and say this is the salary of 5 persons. Now, if you find the median from these 5 values, you'll get $30,000, and for the mean you get like $60,000. Now, which one is more appropriate? Which represent most values? Which will you choose, mean or median? Okay, so that is the question, very important one. Like, if you choose mean, look at the 5 values, $60,000. That means this is like greater than the 4 values. Alright, so is it representative of the most values? Not at all. If you see 30 is almost in the middle, so it can represent the most value. It represents the 4 value at least. Like 200 is different, but for the other value, this value is most representative. So here, median is most appropriate because outlier exists. How I found outlier exists? I can see that $200,000 is very different from all the values. Alright, so yeah, moving on to the like mode. Mode is like the most often the value which occur most times in a data set. Like as you can see here, mode is 6 because like 6 occurs 3 times in this data. Okay, so it is most appropriate specifically for nominal data, which is also categorical. Yes, you can also use for quantitative data, but yeah, mean and median is more appropriate for quantitative data. Okay, so measure of dispersion. This actually gives us the idea about like how the data are dispersed or scattered among themselves. I know if you can't provide an example, this is very tough to understand. Let's say you're a boss in an office, like your office time is like 10 a.m. in the morning. Alright, say so you have like 2 employers, you have like employer A and employer B. So one employer, like you collected the data from the previous 5 days. Alright, like one employer at the first day, he comes like around 10 a.m., then 10:20 a.m., then 10:50 a.m., then 12 a.m., and 12:30. So you can see that like the data values, like for every other data value have like very much distance from all other values. All right. Now for the employer view, you say that someday he come like 10:01, someday 10:02, 9:50. So you can see for the employer view, that data value is very close. All right, from every other value. This is very important line. Okay, now if I ask you that who is more consistent, you can clearly say that employer view is more consistent. Why you say that? It means that you're saying that they have like little scattered in their data or in his data. Okay, so that is why you say that employer view is more consistent. So that is what dispersion do. They give you the idea like how consistent the data is. Okay, like how deviated every other value from each values. Like standard deviation is the most appropriate measure of dispersion to describe the data. Okay, so what do you do? Standard deviation is a number that like how the data are spread out from the average or the expected value. What you need to do, you need to find the mean. Then you need to think about like how other values are deviated from the mean. Okay, so this is what a standard deviation do. Like here the mean is like 3. Okay, 1, 2, 3, 4, 5. So you can describe like like 1, 2, 4, 5 how closely they are with the mean or how they are scattered from the mean. There is a process to find out. I will not explain the theoretical. I'm just giving you the idea so that you can interpret the data like for while you deal with real data. All right. So yeah, as you can see here, like now let us talk about one more like measure, IQR, like what is say interquartile range. Okay, like what is quartile? Quartile means is like you can find like which value is in the 25% of the data, which one is 50% value, which one is 50%, and which one is like 75%. Okay, and so you can like we call it like quartile one. Quartile Q1 means for 25%, and the median is like for 15 percentile, which is like Q2, and 75 percentile is like for Q3. So how we find IQ is like IQ will tell you that the range of the middle 50% of the data. Okay, like how scattered the data is in the middle 50%. That is how IQ give you an idea about the data. So here I have like only like I think like how many numbers, like 7 numbers I have in the data. Okay, all right, 62, 63, 64. Now what you can do is like if you find the middle value is like 70. All right, now this is called the median. This is the 15 percentile value. Okay, this is Q2, and before median you have like 3 value. Okay, 62, 63, 64. Now which one is the median of these 3 value? Is of course 63. Now this is called Q1, 25 percentile value. And on the other hand, after the median, like we have 3 values, 76, 77, 81. Here the median is 77. So you can call the 75 percentile value is like 77. So this is Q3. All right. So we have found like 2 quartile. Now if you like subtract from Q3 minus Q1, the value you get you call the IQR, and this is the like range of the middle 50% of the data. That is how IQR helps you to describe the data. Okay, so now moving forward, like we have like Boxplot. What is Boxplot? Boxplot is like you can describe like measure of central tendency, dispersion. You can tell how the shape or the behavior of the data by finding skewness. You can tell most of the things by using Boxplot. Now, as you can see here, the M here the value we'll get from this line we call the median of the 15 percentile value. All right. And this value is for like Q1, but 25 percentile value. So median is a measure of central tendency, and Q3 here you can see like this is for 75 percentile value. Okay, so you can give like a very good idea about the data. And here is this is the minimum, this is the maximum. So when you subtract from the minimum from the maximum, you can like you can just find the range of the data, and range is another measure of dispersion, which I didn't describe before, like as I felt that it's not really important to describe. So yeah, you can find a lot of things by using Boxplot. Now let's move forward with the data in SPSS. Okay, so here you can see the SPSS file, the data file I have provided you. You need to download the data file, and I already mentioned like if you're watching this video from YouTube, you can check my comment box to download the data file. So here you can see there are like 12 variables, but I will only disguise for specifically for only one variable. Like I will choose like this value is like as you can see in the level we have like highest year of school completed. All right. Now I will describe this variable, and this is a quantitative variable. As you can see, there is no category for this variable, and for the type of variable it should have like a scale variable. Okay, nominal and ordinal is for categorical variable, and scale is for quantitative. So let us find a few things that are already described for this variable. Okay, so this is variable number 12. You have to go to analyze, descriptive statistics, then go to the frequencies, then you can select the variable. All right, then you can click statistics. Okay, let's say you have to click mean, median, mode, and here you can click quartiles. You'll also click percentiles. I think you will get percentiles in quartiles too. Like for dispersion, you can click standard deviation. Range, you can click minimum, maximum. Well, variance is like like when you find the square root of the variance, that is called standard deviation. So it's almost similar to describe the data. All right, like to explain the shape of the data or the behavior of the data, you can find skewness. Okay. And you can click continue. Before continue, I think you shouldn't click percentiles as I already selected quartiles. Okay, so click continue, and for the chart you can you can select. Well, as I said, the quantitative variable has 2 types of variable: discrete and continuous. For the discrete, it is most appropriate if you choose bar diagram, and for the continuous, it is more appropriate to choose histogram. Okay, so here I choose bar charts and continuous. So let's see like how the data looks like. So if you click OK, you will get the output. Okay, so here you can see the bar diagram, and let's check the value like mean, median, mode, skewness. Okay, now to interpret the value, let me choose a interpretation files. Okay, so here I just just select some values to explain that how you can interpret it. Okay, I choose histogram rather than choosing bar diagram. So here you can see from the mean values, what you can say, we can say that for the, as I already described, that these values represent the center of all respondents. Okay, and for the standard deviation, what you can say, which means there is high variability in the data set, as it is 3.2 is quite high, like like every other value has distance, average distance from the mean value is around 3.2. So what you can say that the average distance between other respondents' highest year of school completed and the mean number of highest year of school completed is approximately 3.2 years. And from the skewness, well, I haven't described how we can describe the skewness. Like when the skewness is close to 0, you can say that okay, the distribution of the data is approximately symmetric. When it is negative, you can say that like it is left skewed or like negative skewed. When it is positive, like you can say positively skewed or rightly skewed. Okay, now this is quite interesting. You can get an idea about the histogram too. You can see the mean value is 13. So where the mean value lies, so here is the mean value. Okay, now if you can see that there are a lot of values before the mean value and most of the value is very small. All right, so this is how you can say that the negative values or the left tail is longer than the right tail. Right tail means the upper values from the mean, and left tail you can just say that from the lower values from the mean. So here you can see that. Okay, and from the value of skewness you can also see like minus 0.5. So you can say that there are like negatively skewness in the data set. Now why do you find mean instead of finding like median or mode? You can also find median or mode if you see that like there are too many outliers in the data. Okay, like this is possible that in this data we may have 1 or 2 outliers, and this is very tough to deal with outliers. So in practical situations, what we try to do, we try to delete the outlier or replace the outlier, or just analyze it in such a way that we don't have that much outlier. Okay, so let me check now about the outlier. I think this is quite similar the way I described for the categorical variable, like for the graphical analysis specifically. And now let me find, like, for finding outlier, let us draw a box plot. Okay, so to draw a box plot, in fact, to plot any kind of chart, you can check the option like chart builder. Okay, so when you open the chart builder, let me reset it first. You can just click any type of graph you want. Let's say I need like to draw the box plot. Okay, so select a box. Like this box is for specifically one variable. Okay, there are also some other plots which you can use for many other variables. So select this, then select the variables. Okay, just drag it down here in the x-axis. Okay, and then click OK. Here we get the box plot. All right, so as you can see in the value which is in the middle, which is the median, as you can see here, the median, what is the median? The median is like 14. So you can also get 14 from here. Okay, and this is for Q3 and Q1. As I say, the 25% value is Q1. So as you can see, what is the Q1? I'm not sure where it is. Let me check. Yeah, here it is. The 25% is Q1. So yeah, that is 25. That is median. That is like 75%. Okay, so you can also find it from where? From the box plot. Okay, so here you can, the most interesting one about the outlier, there are 3 values for the outlier. The 231 number values, like as you can see, this is around maybe like 4, or it should be like it's exactly like 5. So this is the outlier. Okay, as you can see in this data, we have 3 outlier. Okay, so while you deal with data, you try to deal with the outlier to go with a better way. Okay, so that is how you can describe the data for specifically descriptive parts. That is what I'm showing you from the last 2 videos. If you're still confused, don't need to worry. From the next videos, we'll go for like regression and ANOVA, where I'll describe more and more. And this video is actually going to help you to understand those topics. And as I said, my goal is to teach you like how to deal with real data. Like I will provide you the data after the video so that you can do it by myself. And if you have any questions regarding this, any topic of this video, you can just ask me in the comment box. And I'm taking some live sessions if you're interested for my live sessions, which I will take from the next few days. And you can knock me here, and yeah, I will try to connect with you. And so yeah, that is what from this video. Thank you very much.